In the Middle Ages, navigators looked to the stars and planets to find their way, and for that they relied on a scientific instrument called the astrolabe. Using this instrument, they could measure the angular distances between celestial objects to calculate latitude. It was the medieval equivalent of the GPS. Today, craftsmen still make astrolabes to celebrate their place in history. Without it, Columbus may not have discovered the Americas in 1492. Back then, astrolabes were hand-forged and hand-engraved. Today, these instruments take shape in two-part rubber molds enclosed in a metal drum. The operator ladles molten pewter into the mold through an opening in the drum's lid. Inside, the mold spins, forcing pewter into every part of this astrolabe plate, complete with geometric engravings on both sides. He molds the dial and pointers the same way. He slices off excess pewter. It will be remelted and reused. He then sands the ragged edges of the plate for a smoother circumference. Next, he pours an acidic liquid onto the astrolabe plate, which blackens the pewter. He swishes the blackening agent around to ensure it covers every surface completely. He places the blackened plate in a barrel full of gritty plastic cones, soap, and water. As it revolves, everything tosses about inside to scrub the surface of the astrolabe plate, but leave the engraved designs black. This process adds definition to the markings. In Columbus's time, they would have used a pumice stone and a lot of elbow grease to achieve this effect. Next, the astrolabe plate goes for a tumble with bits of ceramic to buff the pewter to a glossy shine. Against the shiny pewter backdrop, the geometric markings now stand out. Clearly visible on the front is a map of the sky and the zodiac calendar. And on the back, the mathematical scales are now clearly defined. The elaborate dial undergoes the same processing to enhance its celestial engravings. He now inserts a brass bushing in the center hole of the astrolabe plate and twists it into position. This bushing will act as a pivot for the dial and pointers. Once the dial is in position, he installs a pointer on each side of the plate. These pointers can be turned like the hands of a clock, and the user measures the angle of the stars and planets in relation to the horizon to calculate his location. He caps the bushing with a screw on one side and a nut on the other. He secures the assembly with a specific amount of torque to allow the dial and pointers to move freely. He then slips a metal ring through the top hole of the astrolabe so this instrument can be linked to a chain if the owner wishes. He spins the dial and pointers to confirm that they don't snag on the outer lip of the instrument. Centuries after its heyday, this incredible instrument still fascinates. The amount of information that can be gleaned from holding it to the sky is astounding. More than latitude, the astrolabe can be used to tell time, determine seasons, and predict the future with horoscopes. Of course, it takes a basic understanding of geometry and astronomy to use it. To the trained eye, this astrolabe now reads 1 p.m., proving that this instrument from another era can still provide up-to-the-moment information.